This lesson is going to expand on the topic we previously discussed, which was graphing ax squared. Today, we're going to talk about what happens when we include the c value. So the c value is going to shift the graph up or down. If c is positive, the graph will shift up. If c is negative, the graph will shift down. Right. Also note that the vertex is going to be included here. So the points of the vertex are 0, c. And our axis of symmetry that we talked about in the prior lesson comes back, and it will always be today x equals 0. The axis of symmetry does move once we start moving the vertex more than up and down. Once we move it left and right, there's different coordinates that occur for the vertex. Okay, so if we shift the graph up, it's because there's a positive c. If we shift the graph down, it's because there's a negative c. So if we look at this here, f of x squared, f of x equals x squared is the parent function. What we want to do is take that parent function and subtract 2. So based on what we discussed, the vertex should shift down 2 values. Okay. So step 1, what we want to do is plot points in a table. So if we look here at -2, we want to plot that in for x squared. So -2 squared is 4, minus 2 gives us a value of 2. For -1, it'd be -1 squared, which is 1, minus 2 is -1. And we would continue this and then plot our points. We want to smooth out the curve, and the key word here is curve. It's not a straight line. And we have our graph. And we notice that the parent function, now shown in black, has a vertex of 0, 0. The new vertex becomes 0, -2. So in the end, we shifted this thing down 2 units, and that's called a vertical translation, 2 units down. All right, when we look at this graph here, there's 2 things that occur to it. We have a 4 for an a value and a 1 for a c value. So let's see how this impacts our graph. So again, we set up a table and plug in values, plot the points, and smooth the curve out. So if we look at, just to repeat this, -2, so -2 squared is 4, times 4 is 16, plus 1 is 17. We continue this process of evaluating functions to get our various values. Then we plot them on the graph, smooth out the points, and we notice that the vertex shifted up 1 unit. Also, the 4 tells us from the prior lesson that this is a vertical stretch by a factor of 4. That means that this gets narrower compared to the parent function, and it's a factor of 4, so it gets 4 times narrower. All right, now here's a different type of problem, similar but yet different, is that we're going to graph these values for f of x in a table. So if I have -4, I'm going to square it, which gives me 16. And then -1/2 times 16 is -8, plus 2 would give me a -6. We'll continue this process for all the points. And now we have our graph. And we notice that the negative is going to reflect the graph over the x-axis. The plus 2 is going to take the vertex and shift it up 2 units. And then the 1/2 out front tells us that it's a vertical shrink by a factor of 1/2. Now what we're going to do is take each of these values for f of x and subtract 7. So if we look here for g of x, whatever f of x is, we subtract 7. So each of these values, we're going to subtract 7. And then we have our new graph. The last step is to take f of x, which is shown in red, and then subtract 7 from it. So what we're going to do mathematically is just combine like terms for 2 and -7, which gives us a -5. Now we have our new equation. Right, for real life problems, they introduced this concept of a zero of a function. This is when the y value equals 0, or in function notation, when f of x equals 0. It is also the x-intercept. That's where the graph crosses or touches the x-axis. And it also is a solution to any factor if we were to factor a quadratic. In this particular real-life problem here, they give us this function of a falling object. This is the -16 is part of the formula, and the s sub 0 represents the initial height. This kid here has nothing better to do, so he's going to drop an egg off the top of this building. And he wants to know how long it would take before this egg hits the ground. Okay. So when we look at this, we have to plug the values in for s sub 0, and our function would be negative 16t squared plus 64, and all of that would equal to 0. And there's many ways to do this. One way is to create a table. You could also factor it if you wanted to. So taking that function and plugging values in, we see that the value of f of x equals 0 is going to occur at 2. And t refers to time, so the egg drop will take 2 seconds before it hit the ground. Now, keep in mind here that from 64 to 48, and then from 48 to 0, this is not a linear function, right? It has the exponential 2 on there. So keep that in mind. Also, you might notice that the left part of the graph is not here, and that's because we don't need it in this particular situation. Theoretically, it's there, but in a real world situation, it's not always included because we do not need a negative time. We also don't need any value less than 0 for our range because 0 is ground level. Right? And so we eventually calculate the egg hits the ground.